My name is Lakshit. Today I'm going to show you how to draw a linear comparison graph, simply called LCG plot. Here I have a data set from 7 trials on free fall experiment. Each data is acceleration due to gravity calculated for each trial. There are two sample statistics we need to calculate for drawing a LCG plot. Number 1, arithmetic mean. In general, we call this as average, or sometimes we call this as expectation value. Let's have a look at what is the meaning of arithmetic mean. For a data set, the arithmetic mean is the central value of a discrete set of numbers. Basically, the sum of the values divided by the number of values. This is the formula for how to calculate arithmetic mean. Okay, let's calculate arithmetic mean for our dataset. So here I have calculated the arithmetic mean using online calculator. The summation of all values is 68.01. Now I am going to divide it by 7. So arithmetic mean for our dataset is 9.72 meter per second squared. The second statistical parameter we are going to calculate is the standard deviation. Standard deviation is a quantity which tells us about how much our data values are dispersed around the mean. When the dispersion or variation around the arithmetic mean is high, we get a higher value for standard deviation. How to start calculating standard deviation? We take difference between each data and the mean. Let's have a look at on our data set. First, we take the difference between our first data and the mean. Then we square it. Likewise, we do the same procedure for the each data and we add all them together. Then we divide it by number of samples minus 1. Then we take the square root. I used the online calculator and I found the standard deviation for our dataset is 0.13 meter per second squared. Now we are going to calculate these two quantities. The first one is mean plus 2 times standard deviation and the second one is mean minus 2 times standard deviation. So our case, it will be 9.716 plus 2 times 0.126, which is 9.97 meter per second squared. The other quantity 9.716 minus 2 times 0.126, which is 9.46 meter per second squared. This is called 95% confidence interval. That means 95% of our data values lie within this region. Here we made a basic main assumption. That is, data values are normally distributed. We consider that assumption in this situation. Let's draw the linear comparison graph for our dataset. First, we are going to draw a horizontal line with units. Since our arithmetic mean is around 9.7, I am going to mark 9.7 in the middle. Then I mark this as 9.8, 9.9, 10. Here 9.6, 9.5, 9.4. Our arithmetic mean is exactly 9.72. So I am going to mark that point here. Mean plus 2 times standard deviation is 9.97. So I am going to mark that point right here. Then mean minus 2 times standard deviation is 9.46. So I am going to mark that point here. So then I am completing the box. This is 95% confidence interval for our dataset, and this is actually the experimental side of the plot. Now I am going to draw the theoretical value we are given. This is theoretical side of the plot. The theoretical value for gravitational acceleration is 9.81, which is I am going to mark here. 9.81. Sometimes you are given an uncertainty for the theoretical value, an error. So for this case, I was given the uncertainty is plus or minus 0.01. So then I can complete a box for the theoretical side as well, like this way, which is G plus delta G 9.82, G minus delta G 9.80. Then I am completing the box. Since these two boxes are overlapping each other, we can say that experimental mean, which is 9.72, and the theoretical value, which is 9.81, agree with one another within the accuracy of the measurements. If you look closely, you will notice that experimental mean is less than the theoretical value 9.81. According to free fall experiment, the object might be experiencing air resistance. So that's how a LCG plot is drawn.